Algebra lesson 9-6, factoring trinomials of the type ax squared plus bx plus c. In the last lesson, we learned how to factor trinomials in which the term in front of the x squared term was 1. There was no leading coefficient other than 1. When the leading coefficient of a trinomial is not 1, factoring gets a bit more cumbersome and a lot more difficult. The textbook shows a trial and error method for factoring, which I really don't like very well. It's difficult, time-consuming, and very frustrating for students first learning how to do this. The method I will outline here in this lesson is not only faster, but much less frustrating. It is not in the textbook, so you may need to watch the video several times. It's considered an alternate method, so if you Google it, you may not find this method taught very often, but it is a very effective method. This method for factoring a trinomial with a leading coefficient does not require as much trial and error. To use this method, we must rewrite our original trinomial in such a way that factoring by grouping method can be applied. And I like the factoring by grouping method, it works quite well. All right, so let's look at it. There are some specific steps. The first thing you're going to do is form the product of AC. The last time we did this, we had to have two numbers that multiplied to give us the product of C, but added together to give us the sum of B. Now we're going to find two numbers that multiply to give us the product of A times C, but the sum is still B. You're going to write your polynomial to be factored again so that the middle term, bx, is written as the sum of the two terms whose coefficients are the two numbers you found in step 2, and then you're going to factor by grouping. So let's look at the following number. We're going to factor 3x squared minus 10x minus 8. So I need a product of 3 times negative 8. I need those two numbers, A and C. So I need a product of 3 times negative 8, which is negative 24. But I need a sum of negative 10. So I look at this and I go, okay, I'm going to rewrite this so I can find a product of I'm looking at this going, if I had negative 2 times positive 12, that gives me a sum of 10. So I need it the other way around. I need negative 12 times 2, because that gives me negative 24, and that adds up to negative 10. So those are the two numbers I need. These are the two numbers right here that I'm going to focus on. I'm going to rewrite my original trinomial so that the middle term, negative 10x, gets replaced with negative 12x plus 2x, because negative 12x plus 2x equals negative 10x. So I'm just rewriting my middle term. Instead of having it as negative 10x, I'm writing it as a sum or a difference of something. So I'm going to rewrite this as 3x squared minus 12x plus 2x minus 8. So all I did here, as you can clearly see, is I took this middle term negative 10x, got rewritten as negative 12x plus 2x. Everything else stayed the same. The 3x squared here stayed, and the negative 8 here stayed. Now that I have it written like that, I can factor it by grouping. I always factor first two, last two. So what I'm going to do now is I'm going to take my first two numbers, and I'm going to put a parenthesis around the first two numbers, and I'm going to put a parenthesis around the last two numbers. There always needs to be a plus in the middle. If there's not a plus in the middle, change it to add the opposite, so there is a plus in between these. Then we look for what's the common factor out of 3x squared minus 12x. I can take a 3x out of that. If I divide a 3x out of that, I'm left with x minus 4. And I have my plus sign. What's the common term out of 2x and minus 8? It's 2. And I'm left with x minus 4. This is called factoring by grouping. What we have done here is we have a common term. If you look at this, x minus 4 is common to both of those things. So it comes out one time. It needs to be common to both of them in order to work. So x minus 4 is one term, and then what's left is a 3x and a plus 2. That is my second term. If I was to multiply x minus 4 times 3x plus 2 back together, I would get 3x squared minus 10x minus 8. This method works much better than trial and error, which is the method the book tries to teach you. The more you do it, the better you get at it, and the more comfortable you will be at factoring. Let's look at some more examples. Let's factor 3x squared plus 5x plus 2. I need a product of 6, and a sum of 5. So I'm thinking 5 and 1. Okay, because if I had 5x times x, okay, 5x, excuse me, not 5 and 1, 6 and 1. Let's change that. Oops, 5 and 1 doesn't work. 3 and 2 works. Okay, 3x times 2x gives me 6x. Right, or 3 times 2 gives me 6. And then 3 times 2 equals 6. 3 plus 2 equals 5. So these are the two terms I'm going to use in the middle. So I'm going to rewrite my polynomial, 3x squared plus 3x plus 2x plus 2. And it doesn't matter if you do 3x squared plus 3x first or the plus 2x first. It doesn't matter. It still should work regardless, and I'll actually do it both ways to prove that it does. I can have this as 3x squared plus 2x plus 3x plus 2. Again, factor group first 2, last 2. Common term here out of 3x squared plus 3x is 3x. If I divide a 3x out, I'm left with x plus 1. Here I can take out a 2. I'm left with x plus 1. So my common term is x plus 1. We write that down one time. What's left is 3x plus 2. We write that down. And we have a factor. If I were to write it as 3x squared plus 2x plus 3x plus 2, still grouping first 2, last 2. Here the common term is an x, and I'm left with 3x plus 2. Here the common term is a 1, because I can't take anything out of it. So if you can't take anything out, it's always a 1, and I'm left with 3x plus 2. Right? What am I left? What's my common term? 3x plus 2. What am I left with? X plus 1. And this is exactly the same as this was, just written in the opposite order. All the signs are the same, positive and negative signs, so it still works. So it doesn't matter which order you put these numbers in, as long as you affiliate with, notice you have to put the variable in the middle. Let's look at number 2. I need a product of 42, positive 42, and a sum of 13. I'm looking at this going 6 times 7 is 42, and 6 plus 7 is 13. So 6 times 7, 6 plus 7 equals 13, so I know it's 6 and 7. So I'm just going to write it in different colors so it doesn't get mixed up with the other problem. I have 21x squared plus 6x plus 7x, because that becomes 13x, plus 2. Group first 2, last 2. What can I take out of the first term? It looks like a 3x. 21x squared divided by 3x gives me 7x. 6x divided by 3x gives me 2. What can I take out of the 7x plus 2? I can take out a 1, and a 1 plus 7x plus 2. So the common term, 7x plus 2. What's left over? 3x plus 1. The more you do these, the better you get at them. The more familiar you are with them, the better you'll get at them, and they'll become really easy. They take a little time, but if you know your multiplication tables, you'll see that these come fairly quickly. If you have to go through every possible product and sum, we could be here a long time. Number 3, I need a product of, it looks like that's the same one we did before. I need a negative 24, and I need a sum of positive 10. Okay, oh, it's not quite the same. So I need two numbers that multiply together to give me a negative 24, and add together to give a positive 10. That's going to be positive 12 times negative 2, it is the same one, which is going to give me a positive 10. So I'm going to do 8x squared plus 12x minus 2x minus 3. Again, factor first 2, last 2. Now this one's important because of the fact that if I do first 2 here, remember I said you had to have a plus sign here, so make this plus the opposite, and then factor the second 2 there. All you do is change your minus to a plus the opposite. Make sure that the plus sign is in between your two parentheses. Common term to 8x squared plus 12x is 4x. Now leave me with 2x plus 3. Common term to negative 2x minus 3, I can take out a negative 1 because you never ever want your first term to be negative. You can avoid it. So I'm going to take out a negative 1. So that's going to leave me with 2x plus 3. Just change all the signs. So my common term, 2x plus 3. What's left? 4x minus 1. And there we have it. Number 4 here. We need a product of negative 42 with a sum of negative 41. If my product and my sum are very close together, then I should know that it should be 1 times something. Here I'm going to need a positive 1 times a negative 42. And that would add up to a negative 41 if I added it. So 6x squared plus x minus 42x minus 7. Do the first two, last two. First two. Remember, change this negative, this minus sign to a plus, the opposite. So it goes like that. What can I take out of 6x squared plus x? I can take out an x. I'm left with 6x plus 1. What can I take out of a negative 42x minus 7? I can take out a negative 7. And I'm going to get 6x plus 1. Here's my common term, 6x plus 1. Here's what's left over, x minus 7. After a while, you get really, really good at these. I'm very good at these. I can do them very, very quickly. And you'll realize that this isn't really that much more difficult of a concept to do. Okay, now, the second thing you have to be careful with is sometimes you have a greatest common factor. You need to take that out first. If you don't take it out first, you don't often recognize that you need to take it out last. Sometimes you'll recognize it, sometimes you won't. If there's a greatest common factor, always factor it out first. So let's take a look at this following problem. 9a squared minus 15a minus 6. I know 9, 15, and 6 are all divisible by 3, so I'm going to take out a 3 at the very first step. So that leaves me with 3a squared minus 5a minus 2. Because 9 divided by 3 is 3, 15 divided by 3 is 5, and 6 divided by 3 is 2. Now I need a product of negative 6 and a sum of negative 5. Okay? So I'm thinking negative 6 and positive 1. Negative 6 plus 1 will equal negative 5. So there's my two numbers that I need. I'm going to leave the 3 off here to the side until the very last step. I'm just going to deal with the 3a squared minus 5a minus 2 right now. So I have 3a squared minus 6a plus a minus 2. Do the first two, last two. First two, last two. What can I take out of a 3a squared minus 6a? I can take out a 3a. And I'm left with a minus 2. What can I take out of an a minus 2? I can take out a 1. And I'm left with a minus 2. So I have my common term, a minus 2. What's left over? 3a plus 1. And now, don't forget, we took this 3 out, so we got to put this 3 back at the very last step. Don't forget that. That's why oftentimes I'll underline it or I'll circle it or something so that I don't forget that I took that out at the beginning so that it needs to go back at the end. Let's look at number 6. 18x squared plus 36x minus 14. I know that's divisible by at least 2. I believe 2 is the only thing it is divisible by. So if I look at this and I take out a 2, I take a 2 out of this problem, I'm going to be left with 9x squared plus half of 36 is 18. 18x half of 14 is 7. There we go. Now I need a product. 9 times 7 is negative 63. And a sum of 18. And this is where it gets a bit trickier. Okay. I'm thinking of two numbers like, 9 and 7 equals, 9 times 7 is equal to 63, but 9 plus 7 is, one has to be positive and one has to be negative. In order to have a positive sum and a negative product, one number has to be positive, one number has to be negative. Okay, 63 is not divisible by 2, but it is divisible by 3. Let's see here. If I divided it by 3, I would have a negative 3 and a positive 21. Oh, that works. Negative 3 plus 21 equals 18. So there we go. It's going to be negative 3 and positive 21. So I have 9x squared minus 3x plus 21x minus 7. First 2, last 2. What can I take out of a 3x, or excuse me, a 9x squared minus 3x? I can take out 3x. I'm left with 3x minus 1. What can I take out of a 21x minus 7? I can take out a 7. And I'm left with 2x minus 1. So there's my common term, 3x minus 1. Here's what I'm left over with, 3x plus 7. And don't forget, we took a 2 out right here, so we need to put that back at the bottom over here. So it's 2 parentheses 3x minus 1 times parentheses 3x plus 7. And there you go. 2 more. Before we can see them. 6m squared plus 15mn minus 9n squared. Now notice this time we have variables on both ends. It doesn't get any harder. Don't worry about it. Don't freak out and don't panic. Just put the variables in at the end. We're going to do the same process we did before. I can look at this and go, oh, it's divisible by 3. No variables can come out, but 3 can come out. If I divide it by 3, I get 2m squared plus 5mn minus 3n squared. So I took a 2 out. Now I need a product of negative 6 and a sum of 5. So I am thinking of 1 and 6. I'm thinking of negative 1 times positive 6. If I add those together, that gives me 5. So that gives me 2m squared minus mn. That's where you put the variables back in. So see, this is what you need in the middle. So you have an m and an n that will be attached to those two numbers right there. Minus mn plus 6m and minus 3n squared. That's why these aren't any more difficult. You just have to stick your variables in the middle terms. Again, first 2, last 2. I can take out an m out of my first term, and I'm left with 2m minus n. Out of my second term, I can take out a 3n plus 3n, and I'm left with 2m minus n. So my common term is 2m minus n. What I'm left with is m plus 3n. And don't forget, we took out a 3 to begin with, so we need to put that 3 back here at the end. And there you have it. Not any more difficult. You just have variables to deal with in the middle, so we just put them in. Now let's just say you didn't recognize that you had a greatest common factor. I'm going to show you what you need to do if you don't recognize you have a greatest common factor. Number 1, it's going to be harder, because now you have a larger product and sum you have to deal with. So, that should be a huge clue here. But let's just say you didn't recognize on number 8 here that you could take out a 6. Because I could take out a 6, but I didn't recognize that. So I'm going to just say, okay, I need a product of 18 times 6, which is 108. I need a product of negative 108 and a sum of negative 12. This is going to be harder to figure out product and sums. So I need, my larger number needs to be negative, so I'm going to take 108. Let's see, we'll divide by 4. We have 4 and 27, that doesn't work. 108 divided by 8. That doesn't work. 108 divided by 6. 6 and 18, there we go. And I just started dividing it by numbers. So if I think of 108 as being negative 18 times 6. Negative 18 plus 6 equals negative 12. And this is what happens if you fail to recognize you have a greatest common factor. Number 1, it's harder because of the multiplications. And number 2, you'll have to do one more step at the end. So let's say I didn't recognize this and I go, okay, here's my 2 numbers. So I'm going to have 18k squared minus 18k plus 6k minus 6. First 2, last 2. What can I take out of 18k squared minus 18? I can take out an 18 and a k. And I'm left with k minus 1. What can I take out of 6k minus 6? I can take out, oh look, a 6. And I'm left with k minus 1. So my common term is k minus 1. What am I left with is 18k plus 6. Now I can look at this and say, uh-oh, I got a problem, because I can see right here, I've got a common term that I can take out of that. You may not recognize that, which is why you should always look for the greatest common factor first. But I'm showing you what happens if you forget to look for the greatest common factor first. You can always take it out at the end. Okay, because here's our problem. I'm going to take it out at the end now. Now I recognize this and I go, ooh, look, I can take out a 6. I can factor out a 6. So if I take a 6 out of just the 18k plus 6, I'm left with 3k plus 1. And I still have the k minus 1 that I already had. So now I have 6 parentheses 3k plus 1 times k minus 1, which is what you would have come up with if you'd have taken out the greatest common factor first. So as long as you remember to take out your greatest common factor, you're okay. But a lot of times people don't recognize it. The last thing you should do is look at your problem and make sure there are no common terms within a parenthesis. There's no common terms in the k minus 1, but there's a common term of 6 in the 18k plus 6, so you had to factor that out. This is factoring trinomials in the form of ax squared plus bx plus c.